Hey guys, Worm from Worm's Maths Academy. Quite a few kids have asked me to run through this exam. Um, Obviously, I must have missed it. Maybe I had a bad year and I couldn't be bothered doing it. Don't know. Okay, so a specialist maths exam 2, multiple choice. Should aim for about 30 minutes to get this done. First question, e to the x on x minus 1. Let's clear out everything in our calculator. Here's something I put there earlier. E to the x on x minus 1. Oh, there's a turning point. Looks like we've got an asymptote here, a vertical asymptote, x equals 1. Also got one at y equals 0. So horizontal asymptote, yes. Vertical asymptote, yes. Local minimum, yes. Vertical axis intercept, yep. Must be point of inflection. But we can test. We can put e to the x on x minus 1, double diff it, and see if it ever equals 0. No solution, so that makes sense that it has no points of inflection. Okay, the asymptotes of this thing, well, we know it's got a vertical one at 4, not 8, so we can scrap those. We just need to use x squared plus 1 on 2x minus 8. We can use frac to split it, and we've got that, and then we've got x on 2 plus 2 is our other asymptote, the oblique asymptote. Okay, implied domain function of a set graph. That's just going to translate it up. That's going to reflect it. So it's not going to change the domain. We know a set graph has asymptotes when cos of x plus pi on 4 is equal to 0, because when you divide by 0, it's undefined. So we would get x plus pi on 4 is equal to pi on 2, 3 pi on 2, etc. If we want to get a general solution, we can say we get that solution plus k pi. If I bring the pi on 4 to the other side, we get x is equal to pi on 4 plus k pi. And we know if we take out pi on 4 as a common factor, we get 4k plus 1. N is an element of z. So it's going to be D. All real values except for the asymptotes. Okay, I to the 1 factorial, I to the 2 factorial, I to the 3 factorial. So this is a sequence and it's a sum of them. So on our CAS, we can go into interactive calculation sum of, make sure it's in complex. I, that's not I to the power of x factorial. We want to go from 1 to 100. Does it go to 100 or 99? 100. So 95 plus I. Okay, here I've got two rays and I want to find where they intersect. So z minus 2 means it's been translated 2 to the right. It's got a gradient of 1. So that would come down to negative 2. So y is equal to x minus 2. 5 to the right and 1 up. And we know, obviously that's an open circle. I'm not worrying too much about my working out because I don't really care. 5 pi on 6 is going to go back that way. If you think about it, if tan theta is 5 pi on 6, we're going to get negative, stupid bloody triangle, we're going to get 1, 2, root 3. So it's going to be negative 1 on root 3. So the equation of that line would be negative 1 on root 3, x minus 5 plus 1. So I'm just going to go to the CAS to solve x minus 5 plus 1 is equal to x minus 2. Okay, that gives me my x value. To find my y value, because that's what it's asking us for, I sub it back in and simplify it, and I get root 3, which makes sense. It's about 1.7, because it says for the value of b, and b is the y value. Okay, arg of z is pi on 2, so we know arg of z to the 5 is 5 pi on 2. And then arg of w to the 4 is 4 pi on 4, which is just pi. We know if we divide, we subtract the angles, so we get 3 pi on 2, which is not a solution, which makes sense because it's outside the domain of negative pi to pi. 3 pi on 2 is the same as negative pi on 2, so we get A. Okay, parametric equations, our length is from 0 to pi, the square root of dx dt squared, so if I derive that, I get 3 cos t. If I square it, I get 9 cos squared t. Likewise here, if I derive that, I get negative 4 sine t. If I square it, I get 16 sine squared t dt. You can see here, underneath, I could say 9 cos squared t plus sine squared t. If I take 9 sine squared t out of that, and then I said plus 7 sine squared t, because 9 sine squared t plus 7 sine squared t is 16 sine squared t, but we know cos squared t plus sine squared t is just 1, so we get 9 plus 7 sine squared t, which is b. This one here, you always want to let the u equal whatever's under the harder function. So u is 2x plus 1, du dx is 2, so dx is du on 2. If x equals 1, u equals 3, x equals 5, u equals 11. We know that x is u minus 1 on 2 if we solve this. And if we sub that into here, 2, u minus 1 on 2 minus 1, they're going to cancel. So I just get u minus 2. We know that our terminals are from 3 to 11. dx we replace with du on 2, or we can say a half. 2x minus 1 we know is u minus 2, and then root u. So we get u to the 3 on 2 minus u to the half. 3, 11, a half into u. So it is E. Okay, this one here, a good thing to do first is pick a point. So 0, 0 has a gradient of 1. If I put 0, 0 into there, I get sine of 0, which is 0. So I can scrap that. Cos of 0 is 1, keep that, scrap that, keep that, scrap that. So cos of y minus x, 1 over y minus x. Cos of 1 over y minus x looks like this, which isn't correct. If we just did cos of y minus x, you can see that that's the same equation because it looks like a trig function, sine or cos function. So it is B. Okay, here, sand falls from a chute from a pile, the shape of a right circular cone with a semi-vertex of 60. Sand is added to the pile at a rate of, so dV dt is 3 on 2. The rate at which the height of the pile is increasing. So we want dH dt. So if you think about it, we've got dV dt, so we've got to multiply it by dH dV. So we need h in terms of v. In this case here, we know that tan of 60 is equal to r over h. Bloody hell, I can't do my over h. So h, no, we want r. R is equal to root 3 because tan of 60 is root 3, h. We know that our volume is 1/3 pi r squared h. In this case, we get 1/3 pi, that squared is 3h squared times h. They cancel. So we can say our volume is pi h cubed and dV dH is 3 pi h squared. So we've got to reciprocate that, 1 on 3 pi h squared multiplied by 3 on 2. They cancel. So we get 1 on 2 pi h squared. H is a half. If I put a half into that, I get divided by a quarter, which is the same as multiplying by 4. So I get 2 over pi. Go back to our main screen. 2 divided by, I don't know why they didn't give an exact answer, to be honest. 0.6366, 0.64. Okay, let M have coordinates A, 1, -2, and N have coordinates that, with the coordinates of the midpoint Mn. So there's M, there's N, there's the midpoint. We know the midpoint of Mn is M plus a half Mn, which we know that A, 1 minus 2 plus a half Mn is negative A minus 3. Negative 1 being minus 1, and then 2 minus 1, which is 1. Okay, so what do we get here? We get A minus a half A, which is a half A, minus 3 on 2, 1. We get B in the middle, and then we get negative 2 plus a half, negative 3 on 2. Okay, now if that's equal to negative 5, 3 on 2. What have I bucket up there? Oh, I've stuffed that up. So here, 1 minus, no, 1 plus a half B minus a half. So that becomes a half B plus a half. And then the last one, negative 2 plus a half is negative 3 on 2. Okay, and we know that's equal to that, 3 on 2, and C. So firstly, we know C is 3 on 2, so we can scrap those. This, if I bring my half to the other side, I get a half B is 1, so I get B is equal to 2. So our answer is E. I'm sure if we solve this, half A is equal to, I'm going to add that. So I'm going to get 10 plus 3, 7 on 2. They cancel, so A is negative 7. Yeah, that's correct. Okay, the vector resolute of ij negative k in the direction of M and P is equal to that. So I've got a function that I made in the calculator called vector resolute. And all I do is put in, I think it was 1, 1, -1, comma, MNP. I put it into real because we don't want to have imaginary solutions. M, comma, N, comma, P. Frick. M, N, P. Okay, so the first term is M plus N minus P. So it's these. If we're going to equate them, we know that that's 2, that's -3. So our answer is A. Okay, here, two forces F1, F2 measured in newtons act on a mass of 3 kilograms, produce an acceleration of √3i plus j meters per second squared. So F1 plus 2j, F2 is equal to mass times acceleration. So F1 is 3√3i, 3j minus 2 is plus j. The angle between this and this, the acute angle, what was it? 3√3. The other calculator doesn't have this, which is really annoying. And then j, comma, 0, 2. Where's angle? Let's go exact. Vector angle, cos inverse of √7 on 14. Now let's just check, is that angle acute? Yes, it is. Cos inverse of √7 on 14. If I multiply it by √7 on √7, we get, that becomes 7 on that, 1 on 2√7. So it is D. So that's the opposite of rationalizing the denominator. Okay, a mass is held at rest on a smooth surface. It's connected by a light and extensible string that passes over a smooth pulley of mass, which in turn connects to the same type of string of 1 kilogram mass. This is shown by when the 4 kilogram mass is released, the tension in the string connected so the tension between these two. Okay, so let's first find the acceleration of the system. Let's call this T1. T1 minus nothing is equal to mass times acceleration. Here, we've got 3g minus T1, we're assuming it's accelerating that way, is equal to mass times acceleration. If we add them together, we get 3g is equal to 7a. So a is equal to 3g on 7. So the system is accelerating 3g on 7. We then want the tension here, so let's call that T2. So T2 minus g is equal to mass times acceleration. So we get T2 is, did I just do that the wrong way around? It's g minus T2 because it's accelerating down, so the force down minus the tension force. Okay, if we bring that to the other side and bring that to the other side, we get g minus 3g on 7, which is 4g on 7. Particle is moving along the x-axis with a velocity of u, so it's going that way. At time t equals 0, so here, a force acts on the particle, causing it to accelerate with direction. A is alpha j. So if you know that, we know that if we antidiff that, we would get v is the integral of alpha j dt, which would be alpha t j plus some constant. So all it's doing is dragging it upwards because we're adding that component onto it. So it's going to have a horizontal component and it's going to have a vertical component. Slows down, stop, no, that doesn't happen. The particle moves, travels along the x-axis, no, because it's being pulled upwards. Parallel to the y-axis, no, because it's still got that force going to the right. Particle moves in a circular arc, no, it's not going to be a circle, it's going to be a parabola. Okay, a variable force acts on a particle, causing it to move in a straight line. The velocity in meters per second is given by this. Now remember, if you want acceleration, it's v dv dx. So e to the x sine x times d dx of that same thing. I'll just stop that real bad there. Now, I just realized, make sure your calculator is in radians. Okay, that's a bit ugly, simplify. Sine x e to the 2x, sine x plus cos x. Okay, so it's none of those, it's one of these two. Is that right? Did I copy it down? Yeah. If we expand it in, we get sine squared x e to the 2x plus, well, we can just bring the sine in, e to the 2x, sine squared x. Then we're going to get sine x cos x, which we know is a half sine 2x. So it's A. A particle is held in equilibrium by three planar forces, coplanar forces. Angles between alpha, beta, gamma. Beta equals 2 alpha. So F1 on sine alpha, Lami's theorem, is equal to F2 on sine beta. F1 over F2 is sine alpha over sine beta, which is sine alpha over sine 2 alpha, which is sine alpha over 2 sine alpha, sine beta. They cancel. I get 1 over 2 sine beta. No, cos beta. It's cos. Which is alpha. Don't know why I changed to beta, but it's supposed to be alpha. Okay, so 1 over 2 cos alpha, which is a half sec alpha. The masses of 36 athletes and mean of 65. Standard deviation is 4, 98% confidence interval. So we just go into interval 0.98, sigma is 4, 65, 36, 63.4, 66.6, 63.4, 66.6. Okay, x and y independent random variables each has a mean of 4 and a variance of 9. The random variable z, x, ax plus by. So e of ax plus by, we know is a e of x plus b e of y, which is 4a plus 4b, and that's equal to 8. If you have var of ax plus ay, by, that's a squared var of x plus b squared var of y, which means we get 9a squared plus 9b squared is equal to 90. So we can just chuck them into a calculator and solve it. I'm just going to use x because it's easier. What was it? 4x plus 4y equals 8. 9x squared plus 9y squared equals 90. Solve for x and y. Didn't x. -1, 3. It's not there. 3, -1 is the random number function of a calculator is designed to generate random numbers that are uniformly distributed from 0 to 1 when working a population. Mu is 0.5 and sigma is that. When checking a random number function, a particular calculator sample of random numbers was generated and found to have a mean of that. So x bar is 0.4725, mu 0.5. It's less than. Sigma is 0.2887, and we want to find the p-value, and n is 100 from there. So we've got to go into one sample z, test the variable, less than, mu was 0.5, 0.2887, I think it was. Yep. X bar was 0.4785, was it? 4725. That was 100. P-value 0.1704. Okay, so that is the multiple choice for 2019. Hopefully I'll get time to do the extended response today. And hopefully this is some use. Don't forget to give it a like, share, subscribe, thumbs up, whatever everyone else tells you to do. And good luck next week on the exam.